We are now going over the revision slides covering from chapter 3A all the way to 3F. So let's just get started. I'll probably break this up into two parts, okay? So this chapter mainly focuses on fractions. So as you know, fractions are separated into two parts. You have the numerator mentioned here, and you also have the denominator, okay? So basically how it works is the denominator tells you how many total parts there are, and the numerator tells you how much is technically shaded in this case. So if you have a look here, 4/7, very straightforward, okay? Now, equivalent fractions. Equivalent fractions just mean that they are equal in value. So you have two fractions, they could technically have the same value. So in my example here, I have 3/5 and 6/10. These two are exactly the same value, so there's no difference at all. Now, this is what's really important. How to create equivalent fractions. It's pretty easy. You're just going to multiply or divide the numerator and the denominator by the same whole number. So in my example here, I've got 2/7. I've multiplied both of them, both numerator and denominator, by 5, and I end up with 10/35. That's an equivalent fraction right there. They have the same value. Vice versa, if I were to divide in my second example here, I've got 6/21. I divide both of them by 3, and I end up with 2/7. Okay, so now these two are equivalent fractions. So I'll just go through like a couple of them real quick. It says here, rewrite the following fractions with a denominator of 40. So I know that I have to turn all of these fractions into 40. So I'll just do this real quick. I'll just set it up. So you just got to ask yourself, what do I do to the 5 to get to 40? Now, you're just going to do times 8. And if I multiply the denominator by 8, I also have to multiply the numerator by 8 as well. So I end up with 24/40. In this case, for the second one, I'm going to multiply by 20. So I also multiply by 20 here. So this gives me 20/40. Over here, 120 to 40, I'm going to divide by 3. And that means for 36, I'm also going to divide by 3. That gives me 12. And finally, 4 into 40, it's times 10. 7 here times 10, that gives me with 70. Okay. Alright, next thing is simplest form. This is really important. An equivalent fraction with the lowest possible whole numbers in the numerator and denominator. That's what simplest form technically means. So to do that, you got to find the highest common factor, okay, the HCF, and then divide the numerator and denominator by this number. So let's just go do it. So I have an example here, 12/18. The best thing you can do is just write out 12 and 18 out, and you're going to write out its factors. So for 12, I have 1, 2, 3, 4, 6, and 12. And for 18, I have 1, 2, 3, 6, 9, 18. And what you're going to do is you're going to find the highest number they share in common. In this case, I have the number 6. So what I'm going to do now is divide both of these numbers by 6, and I end up with 2/3. Now let's just go over here, 8 and 20, so I'll just do the same thing as before. So I'll write out 8, I'll write out 20, just write out its factors. So for 8, it's quite easy. For 20, it's just a little bit more, but it's not too bad. And then you're just going to highlight the highest number they share in common, which is 4. So divide by 4. Divide by 4. This equals to 2/5. Same thing for the next one. I have 25, and then I have 15 here. So I have 1, 5, 25, 1, 3, 5, and 15. So I've got 5 here, 5 here. Divide both of these numbers by 5. So this equals to 5/3. Alright, next thing we're going to do is we're going to learn how to add and subtract fractions. So just follow these 3 steps here. Step 1, check the denominators. They must be the same. If they're not the same, move on to step 2. Okay, you have to find the LCD and rewrite the fractions so that they have the same denominator. So this plays into the part of you writing equivalent fractions here. So we will do that soon. And then finally, step 3 is just add or subtract the numerators. Keep the denominators the same. So over here, I've already done it. So if you have a look here, in this bottom section here, I am finding multiples. I'm finding multiples of 3 and 4. And I just write up to a certain number. And then what I need to do is find the lowest number they share in common. In this case, it's 12, which I have highlighted. So now what I need to do is I need to rewrite the fractions. 2/3 with a denominator of 12. As you can see here, I multiplied the 3 by 4. And that means I also have to multiply the numerator by 4 as well. And that's what gives me 8/12 here. I'll just do this as blue. And then green can be this one here. Same thing, what I did for 1/4 here is I had to rewrite it as a denominator of 12, multiply this by 3, multiply the numerator by 3. I end up with 3/12, and hence I've rewritten it here. Now, once the denominators are the same and everything looks right, I'm just going to add the numerators, so 8 plus 3, which equals to 11. Okay. Same thing if you're doing subtraction, it's same exact steps. So over here, these are just multiples. And I found that 6 is the lowest one they share in common. Just redo the same thing. Let me write this out as blue. So circle blue here. And then circle green here. Just based on the color of the pen I'm using. And you'll see that it matches up, okay? Now, what's really important here is that the 5/6 fraction here doesn't change because the denominator is already what we want it to be. So all we technically had to do was just change the second fraction, so change from 1/3 to 2/6. And then, yeah, just chuck it in. Subtract the numerators, 5 minus 2, which equals to 3. Now, when you go 3/6, you need to make sure you simplify it to be 1/2, okay? Next thing is mixed numbers. So you just got to understand what mixed numbers are. So they just consist of a whole number and then a proper fraction like this. So my example here is 2 1/4. So I have 2 whole circles and then I have an extra 1/4 shaded, okay? Now this is a really important step. Whenever you're given a mixed number, just always convert it to an improper fraction, okay? Makes your life 10 times easier. Very, very important. Now, I've already done this, but I'll just walk you through it. So what I've done is I've just written out the fraction again, so 2 3/5. And what I do is I take the denominator and multiply it by the whole number, 2. So obviously 5 times 2 equals 10. And once I find what that multiplies to, I'm going to add it to my numerator here. So it now becomes 10 plus 3, and that is 13. Now this 13 becomes your new numerator, so you now write it as 13/5. Now, in my next slide here, I've sort of written a process as to how you would do it. So I've written it as whole number, numerator, denominator. And what you do is you do denominator times whole number. This is number 1. And then whatever you find from number 1, you're going to add it to the numerator, which is here. And whatever answer you get, that becomes the new numerator. So that means your final answer is just new numerator over denominator. So if you just follow these steps here, you'll pretty much convert mixed numbers into improper fractions every single time, okay? Now this is where you start combining the 2 steps together. So you have to convert, and then you also have to do the adding and subtracting part. So let's just convert these fractions first. So for part A, or question 1, I'm going to convert it to be, so 8 times 3 is 24. 24 plus 5 is 29. So this fraction now becomes 29 over 8 minus, let's see here, 4 times 2 is 8. 8 plus 3 is 11, so 11 over 4. And now that I've got it set it up, I now need to make sure the denominators are the same. I can tell you for sure that the lowest common denominator is going to be 8. So the first fraction doesn't change, but my second fraction, I need to multiply by 2. So this now becomes 22 over 8. Now, while these are lined up, I can just subtract the numerators like normal. 29 minus 22, which equals to 7 over 8. Just like so. For question 2, I'll do the same thing. So this becomes 5 over 2, because 2 times 2 is 4. 4 plus 1 is 5. Minus 6 times 1 is 6. 6 plus 5 is 11. So 11 over 6. Now just carry on like normal. Just proceed. I know that LCD is going to be 6. So with my first fraction, I'm going to multiply by 3 to both numerator and denominator. And this is my equivalent fraction for my first one. And now I'm going to write it like this. And since the denominators are the same, I can just go 15 minus 11, which is 4 over 6. Now make sure you always simplify, okay? Simplify. I'll just say simplify here. And if you were to simplify this fraction, you actually end up with 2 over 3. Alright, next thing we're doing is multiplying fractions. So just some notes here. Denominators do not need to be the same. So let me just underline that. Before you can proceed, multiply the numerators together and multiply the denominators together. Mixed numbers must be converted. And then if possible, simplify or cancel the fractions before multiplying. Okay? So how does multiplying fractions work? So visually, this is what happens here. So I initially have 3/4. So this is original. What do I do? So this is the original. 3/4. I now need to find half of 3/4. So if you have a look here, 3/4 has been shaded. And now what I have done is just I have split off these 1/4 and I just cut them in half in each block. So one block here, one block here, one block there. And then basically all you need to do is just count them pretty much. So where's the halfway mark between the shaded area? So you know it covers this side right here. And if you have a look at my diagram, it is exactly 3/8, okay? Now, when you're cancelling is super important. It makes your life 10 times easier. So what you're going to do is you're going to look at the cross diagonal of the fractions. As you can see, I've circled the diagonals for you. So you got the red circles and then you got the green circles, okay? Basically, if you can simplify them, just do it straight away. If you can't, then leave it as is. Now, to do that, what you're going to do is you're going to divide the diagonals by the common factor, okay? So I'll show you in this case. I'll show you a couple of examples here. So I have 2 over 5 times 3 over 7. If I were to look at the diagonals here, I don't see anything. And then if I look at the diagonals between 2 and 7, I don't really see anything. So what you can do is just multiply across like normal. And you just end up with 2 times 3, which is 6. 5 times 7, which is 35. Okay, that's it. The next question is 8 over 5 times 7 over 4. Just check the diagonal. So just a note, I can see 8 and 4 can be simplified. And now what you need to do is find the highest common factor between 4 and 8. So if I write it off on the side here, 4 and then 8, So I have 1, 2, 4, and then 1, 2, 4, 8. As we can see, 4 is the highest common factor between them. So what I'm going to do now is divide both these numbers by 4 respectively, and this becomes 2 over 5 times 7 over 1. And this makes my multiplying a whole lot easier, so I can just multiply like normal. Just go across like that. 2 times 7 is 14. 5 times 1 is 5. This last question, it's just the same thing as before when you're converting mixed numbers, but it's just combined together here. So I now got 3 and 1/3. So 3 times 3 is 9. 9 plus 1 is 10. It becomes 10 over 3 times over here. We got 5 times 2 is 10. 10 plus 2 is 12. Just like so. And now you're just going to check the diagonals. I can see 10 and 5 work. And I can also see 12 and 3 work as well. So for 10 and 5, I've got 1, 2, 5, 10. And for 5, I got 1 and 5. As we can see here in the yellow, 5 is the highest number they share in common. So what I'm going to do is I'm going to divide both these numbers by 5 here. And now for 3 and 12, 12 and 3, 1, 2, 3, 4, 6, 12, and then 1 and 3. As we can see here, the number 3 is the highest number they share in common. So you're just now going to divide these numbers respectively, like so. Now this may look like a hot mess right now, but if you were to rewrite the fraction again, it becomes 2 over 1 times 4 over 1, like so. And then you just do that, it equals to 8. Dividing fractions, it's pretty much the same as multiplying fractions, but you have one extra step. And you just need to do this right here, all right? Keep, change, flip. So this is the phrase, keep, change, flip. KCF, not KFC. Okay, remember that. Now, K just means keep the first fraction the same. Change means change a division sign to a times. Flip means flip the second fraction around. Now, what do we mean by flipping the second fraction? Flipping the second fraction just involves something called the reciprocal. And what that means is you're going to swap the numerator and the denominator positions, okay? For example, if A is numerator and B is denominator, you're just going to switch their positions, okay? Switch positions. So it now becomes something like B over A. That's what it should look like. So if you have a look here, this is just an example that I've just done for you. So 3 over 8 divided by 5 over 4. Just apply KCF first, and that's what I've done exactly. Then you just follow the same steps as multiplying fractions. So I've got the 4, I've got the 8 here. I can simplify them. So let me just rewrite this out here. Now this becomes, so I'm just going to do something like this. So cross this off, it becomes a 1. Cross this off, it becomes a 2. I now got 3 over 2 times 1 over 5. And this just equals to 3 over 10. Okay. Let's do a couple more examples here. So we got 2/5 divided by 3/7. Apply KCF like so. No diagonals, so you just multiply across like normal. It becomes 14 out of 15. Second one, you got 5 over 8. And then times 16 over 15. Like so. Now I'm just highlighting the diagonals. Oh, ooh, what happened here? Alright, here we go. Like so. I'm just going to cross this off to be 1. That becomes 3. That becomes 2. That becomes 1. And you'll know the reason why once you find out what the highest common factor is. The highest common factor between 5 and 15 is 5. So divide both of them by 5. And the highest common factor between 8 and 16 is 8. So divide both of those numbers there by the number 8. Now, this looks like a mess. So what I'm going to do is I'm going to rewrite the fraction here like so. And since this looks a lot nicer, I can now just multiply like normal. Watcha! And now number 3. Now you can do two things here. You can convert into the improper fraction first, or, well, like there's only one thing you can do here. It's technically convert to the improper fraction and then apply KCF, but that's two separate steps. But what I plan on doing is combine converting and KCF together. So that's what I'm going to do. So 4 times 2 is 8. 8 plus 1 is 9. So I'm going to write 9 over 4. Now instead of writing dividing, I'm going to write times. And then let's just convert this improper fraction here, 1 and 1/3. So 3 times 1 is 3. 3 plus 1 is 4. So technically this fraction here becomes 4 over 3. But because I'm applying KCF at the same time, it now becomes 3 over 4, like so. Now because there are no diagonals here, I can just simply multiply across. And this becomes 27 over 16. Now, make sure that whenever you're doing these kinds of questions that your answers are written in simplest form, okay? Read the question carefully to make sure that the answer wants you to write it in improper fraction or mixed number. But if they don't mention anything, then the default is an improper fraction, okay? So make sure you do that. Alright, adding and subtracting negative fractions. So this pretty much is the same steps as we learned previously, but obviously you're going to have like this signage stuff and you're going to need to combine the signs together. It's pretty straightforward, okay? Basically, if you see two of the same signs, it becomes a plus. If you see two different signs next to each other, it becomes a minus. That is the rule, so make sure you just follow that, okay? So, in my first example here, I got a plus and a minus. This just combines to make a minus here. So I'm going to rewrite this as 2 over 7 minus 5 over 7, okay? Now, because the denominators are the same already, I can just apply the operation to the numerator. So it becomes 2 minus 5, which equals to negative 3 over 7, like so. And we're done. Now over here, we see two minuses. It changes into a plus. So this becomes 2 over 3 plus 4 over 3, like so. Now you just go 2 plus 4. In the numerator, it becomes 6 over 3. And then this just turns into positive 2, like so. Now with this next one here, number 3, this is where it sort of gets tricky. So the signs combine to make a minus. So what I'm going to do is I'm going to write 1 over 5 minus 1 over 4. And then you just got to make the denominators the same. So just do the same shenanigans as before. So this becomes 20. That becomes 20 as well, because the LCD is 20. And then you just ask yourself, what did I do to the 5 to turn into 20? It's times 4. So just create the equivalent fraction and vice versa. Now that they are the same, I can just write this as negative 1 over 20. As you can see, the pattern just keeps on going and going. It's just one extra step that you have to do. Okay, now with this final one here, this becomes a plus. So let's just do this. So this becomes negative 7 over 3 plus, and let's convert this mixed number into an improper fraction. It becomes plus 11 over 3. Now what you got to be careful of here is this actually becomes negative 7 plus 11, okay, over 3. And obviously negative 7 plus 11 just equals to positive 4, so your final answer is 4 over 3, okay? Multiplying, same thing, okay? So same rules. If I'm multiplying like this, so let me just best phrase this. So if I got two different fractions, or if I got fractions with different signs, it's a minus or negative. If I got two fractions with the same sign, it's a positive. That's how it goes. So same rules as multiplying here. Do I see any diagonals? Nope. So let's just multiply like so. So it becomes 8 over 15. But because I got a positive fraction and a negative fraction, my final answer is a negative number like so. And then over here, I don't see any diagonals. So let's just keep going. I end up with 6 times 3 is 18. And then 5 times 4 is 20. Actually, there is actually a diagonal. I forgot. It's right here. It's 6 and it's 4. The highest common factor is just 2 between the two of them. Okay? So what happens now is I rewrite this as 3, rewrite this as 2. So let's just rewrite the whole thing. Negative 3 over 5 times negative 3 over 2. Now 3 times 3 is just 9. 5 times 2 is 10, like so. And because I got two of the same signs being multiplied together, I end up with just a positive fraction. Negative fractions here. Let's have a look. So let's see here. Same thing, apply KCF. So negative 2 over 5 times negative 4 over 3. Do you see any diagonals here? Nope, not really. So you're just going to multiply across like always. 2 times 4 is 8. 5 times 3 is 15. Because there's two negative signs right here, it just becomes a positive. So you just leave it as is. Now the second one, I'm going to convert this real quick. So negative 4 over 3 times 1 over 3. Now you're wondering, how did I get 1 over 3 here? So I'm just going to highlight this 3 right here. So this 3, so this 3 here, another way of writing 3 is 3 over 1. And as I applied the flipping rule, the 1 and the 3 just switches position. So instead of writing it as 3, I now write it as 1 over 3, okay? Now, just check the diagonals. If you don't see any diagonals, just keep going like normal. So 4 times 1 is 4, 3 times 3 is 9. And then you got to check yourself. I have a negative sign here, and then I got a positive sign there, technically non-existent. And that means my final answer should be a negative number. Alright, that's it for the first half. I'll come back with the second half real soon, okay?